All right, this is going to be lesson 1-3. We are on parallel and transversal lines. So, class, Gio and Chris, what standard are we on?
Okay.
Parallel and transversal lines. Give me the standard.
I don't have the thing. The thing's in the back. Come on, Gio. Come on, you. Wait.
Parallel and transversal lines. They're trying to figure it out.
I'm kind of slow, sorry, guys.
We got this. Standard.
Wait, this
Standard C.
What is standard C?
line and angle relationship?
That is correct. Line and angle relationship. Congratulations, you got it. Okay. So, let's talk about parallel lines really quick. So, parallel lines, they can be very, very far apart. So, maybe these aren't the best examples. So, like this one could be really far over here. It's always parallel if what? What is the defining characteristic of a parallel line, guys?
They don't cross.
They
Yeah.
don't cross.
So they have
That can be confusing because, I mean, generally speaking, you are correct. In 99.999% of the case, they will never cross. So I'm going to put that in the side notes, but that's not the definition of how I define parallel lines. So I can say here, never cross.
they never intersect.
Cross an asterisk. Asterisk says, hey, there's an exception to that rule. Here's the exception. Are you ready? Exception to that rule is
They can be really, really close.
right there.
Right?
When they're on top of each other, then they cross at infinitely many points. I guess this isn't the exact same slope either. Now they're exact same slope. So now they're the same exact line. So in this case, they cross at an infinite number of points, I guess. But usually you're right. They'll never cross. But how do we better define parallel lines again? Do you remember?
They never intersect.
They have the same slope.
Ah, there it is. Gio has it. Hopefully you guys heard that in the microphone, but same slope. So I'm just going to say here, same slope.
You didn't say it.
Okay, and then I want to describe a transversal line. So go ahead and draw another few parallel lines. So I'm going to draw some parallel line that looks like that. And because I have technology, I can just select it, copy paste to make sure it's the exact same slope. Here's my parallel lines. It doesn't matter where I drag them. They're always going to be parallel because they have the same slope. That's how I defined it. I want to define now a transversal line. So let's call this guy on the left here transversal. Do you guys know what a transversal line is before I even tell you?
No.
No? Okay, so a transversal line means it cuts through parallel lines. So here's my transversal. I'll do transversal in red. Here's my transversal line. And I'll even label him for us. So this guy right here, that is our transversal. And I do have bad notation here because what I should be doing is every parallel line, I should do these little arrows on them. Arrow, arrow. And then I can say these are different parallel lines. And I can maybe say these are even different parallel lines. And because this transversal doesn't have any of these arrows on them, therefore it is a transversal. All right. So we have the definition of parallel. We have the definition of not perpendicular, but transversal. In notation, I should also put this in parallel lines. Can we put this on the side notes also? That the way of saying that, let's say if this was line, we'll call this line L and line M. If I want to say L and M are parallel, I say L is parallel to M. That's the symbolic representation of saying parallel. So this is the symbol here. That's the symbol for parallel. All right. So we need to learn how to figure out what angles are congruent. That is all today. Today is how do I figure out what angles in here are congruent to what other angles. So now we're going to go into our new and might be our final topic here, which is angle congruencies. So let's write that out on the side here. Angle congruencies. Angle congruencies. Okay, spell correct, Mr. Sindel. Congruencies. Okay, so let's go ahead and draw that same diagram where we had parallel lines. Make them really big because we're going to draw on this like a ton. Oh, I should have just copy pasted. You're right, to make sure they're exactly parallel. It's really good for the notes.
Like you're signing.
Yeah, sound effects make everything better. And I'm going to go ahead and color code our transversal also. The red is the transversal. And you don't need to label it in your notes because you already have it, but I will for this one. Transversal. That's that one right there. And I am going to do tick marks or the arrows on here to make sure that we know that we are parallel lines here. Okay, so how do I figure out what angles are congruent? And I think the best way to do this is I'm going to do this in blue to make sure I know what angles. I'm going to label all these as angles. So I'm going to say this is angle 1, 2, 3, 4, 5, 6, 7, and 8. I think it's pretty clear what angle 8 is. Angle 8 is not this 180 degrees. It's only this intersection of the line. That's angle 8. Okay. Remember how I warned you guys that geometry is all about vocab?
Yeah.
This is becoming true today. There's a lot of vocab. Here we go. Well, maybe I should have drawn this smaller now that I realize it, but I'm going to say that. Well, first of all, let's do some review. Angle 1 and 3. So angle 1 is congruent to angle 3 by what? Why are 1 and 3 congruent?
They're the same angle.
They are the same angle in terms of the measure, but they're not exactly the same angle because of their location. I agree that they have the same measure, though. But how do we know that? There's a name that's associated with going across like this. We learned it yesterday.
They add together to.
Nope, they don't add together to be 180.
To 90.
Hey, Chris, say it louder.
Vertical angle.
Vertical angle. Yes, that's right. These are congruent because, so this is the statement that I'm writing, and this is the reason. So statement and reason. So the statement is angle 1 is congruent to angle 3. The reason, vertical angles. Can I abbreviate here? This vert means vertical and then angles. Vertical angles. And if you don't like abbreviations on the side, and you don't have to write this again, but if you don't like them or you think you're going to forget in about a week, vert means vertical, and ang means angle. I'm going to do lots of abbreviation because I don't like writing. All right, so another review one. Angle, I'm going to write my statement kind of big. The measure of angle 1 plus the measure of angle 4 equals 180. Why do I know that? 180 degrees.
Because they're next to each other.
They're next to each other, but more specifically, they're adjacent, but they're also on a line. And they have a very name. It starts with an L.
Linear pair.
Hey, nice, Chris. Yeah, it's linear pair. And again, I'm abbreviating here. Maybe linear pair. I can fit it all in here. These are linear pair. They're on a line. They add up to 180. A line always has 180. And when I add them together, they're 180, so we give that name a linear pair. All right, this is all review so far. I haven't learned anything. We're just making sure we know what we're doing. Now for the new stuff. I'm going to say, how do I relate these angles to the ones down here? Because we can get all of these angles. In the homework, we were able to get all these angles, but now that I have the second line, how do I get those? And here's the first and usually the most famous in my class last year at least. The measure, actually I'm not going to do measure. I'm just going to say angle 3 is congruent to angle 5. So 3 and 5. Do you guys kind of see this? I'm going to draw it here roughly, and then I'm going to undo my work, so it's not going to be permanent in the notes, but just so that we can see what's going on here. Maybe, do I have a highlighter? Oh my god, I have a highlighter tool. Okay, so do you guys see this Z shape? The inside of the Z shape are the same angles. We call that inside of the Z shape something special, and maybe Arrow remembers from last year. Inside of the Z shape, we call those alternate interior. And I need to spell this all out, so I realize in retrospect that I need to move these over, because if I don't write it all out, I can't just immediately start abbreviating it. No, I don't want to move him too. What are you thinking, computer? Why is it highlighting? Oh, wow. It's weird that it randomly highlights. Okay, well, let me just erase those and move it over then. That's really weird. Okay. I'm going to rewrite this because I need to write alternate interior over here. Alternate interior. So they're interior angles. They're on the inside of the Z. And I'm saying that angle 3 is congruent to angle 5 by alternate interior. That's a horrible 5. Try again, Mr. Sindel. Angle 5. That's a little bit better. By alternate interior. And with this fact alone, I can figure out the rest of these. Now that I have a rule that connects these two, well, then I can say, well, 5 is equal to 7 by
5 to 7. Because
angle 5 is congruent to angle 7 because
They're
vertical angles, exactly. And then I can say, well, 5 and 8, I can figure out 8 because 5 and 8 are a
pair.
linear pair. And I can figure out 5 and 6 because they're also a.
Linear pair.
So I have one rule that connects these two, and that's called alternate interior. So let's write all the angle congruencies just to finish up our example. I'm going to go switch to red. No, black. We haven't used black yet. So I'm going to say angle 1 is congruent to. What is it also congruent to? We already have it up here. Angle 1 is congruent to.
Angle 4.
No, angle 1 and 4 are not the same
Wait,
angle.
3.
Angle 1 is congruent to angle 3, which is congruent to
Angle 7.
angle 7
Angle 5.
and congruent to angle 5. Yeah, so it's pretty easy to just see it, but the reasoning is the hard part. All the small ones are the same. All the small ones are congruent. And then doing the other side, so if I want to say angle 2 is congruent to what?
Angle 2 is congruent to 6.
To angle 6, which is congruent to
Angle 8.
angle 8. Ooh, I need to do an angle here.
angle 4.
I forgot my angle notation. Angle 6, which is congruent to angle 8, which is congruent to
Angle 4.
angle 4. Yeah, you found all the congruencies. So there are two things that you really learned today, and I need to have those two things in the summaries. And those two new things came right here, and I'll say them directly, ready for your summaries. We learned what an alternate interior was, and you might want to think of this as the inside of the Z. And then we also learned how to use that to figure out how to connect these angle congruencies to the top angle congruencies. So we learned how to connect the parallel lines with the transversal to find congruencies. So two things, I'll try to make those shorter. Alternate interior and how to get congruencies between parallel lines with the transversal. All right, so that concludes the notes. Look out for the worksheet for those of you listening online. And I will see you guys later. Thanks for watching.
Do we have
Say
to-
bye, Gio. Say bye, Chris.
Bye.
Bye.